to lecture number 3 of our series on AI engineering, and this is based on the book by the same name, and it is written by chip-huyen. And today we are going to talk about RAG. Well, actually, RAG and agents both, but we'll just touch agents as a concept, a brief overview, because this actually belongs to I think chapter number 6 from the book. Okay, the book has a lot of chapters. Like for the first and second lecture, we followed the book exactly to the word, that we followed everything that chip-huyen talks about in AI engineering. But I think that she starts off lecture chapter number 3 in the book with evaluation. And while it is very important to know about evaluation frameworks, I think RAG and agents are at a higher priority today, and so we will spend the entirety of lecture number 3 discussing about RAGs. Another version of this lecture should be discussing about agents, because RAG is a very big topic. I thought that it's best to go in detail of it. Okay, so let's get started. First of all, we have the definition, right? First of all, I think we should start with the definition. So, what do you mean by RAG? RAG stands for retrieval. Retrieve Augmented Generation. Okay. So this is basically a pattern. Okay, in a way you can think that the RAG pattern is basically made to allow the model to retrieve information. So it's a retrieval of information from any external sources. So this is a RAG architecture, and here you're going, the whole idea of RAG is to retrieve information from an outside resource. What happens is, usually when you're talking to ChatGPT has access to your prompt history and it talks to you according to that prompt history. That is called as the context. Okay. Now, when I talk about RAG means that ChatGPT also has access to a database which has a lot of information that is relevant to the topic that I am discussing. So, if it has access to that information, then we call it RAG. Okay. And in comparison, when you talk about an agent, okay, so an agentic pattern is basically to allow the model to use tools. Tools are basically any function that allows the model to communicate with the external environment, like web search, okay, or maybe weather API, which is fetching data from the weather API, right? It will get this information and it will give it back to you. That's what an agent does. It interacts with the outside world based on your commands. So that is the whole, I would say, concept about RAG. And RAG versus agents, okay, if you had any doubt. So RAG pattern is used for constructing context. So like I said, that whatever you talk to in a chat window, that is called as context. But sometimes, for example, if you want your chatbot to know specifically about, say, lip balms, I love lip balms, and I have a whole PDF on lip balms that I wanted to refer to before talking to me, right? I wanted to know what it means. Or for example, I want my chatbot to write a letter of recommendation for me, or a reference for me, or anything. I have some rules that you have to follow, so I can give it those rules and then it will refer to those rules and then make a LOR for me. So that's pretty much what the RAG pattern starts off with. So coming to a definition, we will say RAG is a technique that enhances a model's generation capacity or generation capability by retrieving relevant information from an external memory source. So that is a very thorough definition of what RAG does, and this is precisely what RAG does. It just retrieves information from an external source, okay, and it then generates the output based on this information. So the external memory source that we're talking about, it could be anything, okay. It could be a database that I have connected to. It could be a previous chat window also, okay? Or it could be the entire internet. That's what the web search API does. Perplexity, if you have heard of, that is actually in a way, just using the web search API, getting all contextual information through RAG and then generating the output. Okay. Now, how did the term RAG came into being? So the term RAG, or Retrieval Augmented Generation, for knowledge intensive. So originally, there was a person called Lewis, okay, and Louis AL published. So AL means his team, Lewis and his team. So they published a paper in 2020 where they first talked about retrieval augmented generations for knowledge intensive NLP tasks. Okay. So this paper is the one that proposed this architecture. This is the very basic RAG architecture, and they proposed this architecture where they used it as a solution that when you have a knowledge intensive task where you want all the available knowledge and you can't put all of that knowledge as context, you can't just type all of that information. That's a lot of information. You just want some bits of that information you want to query through. For example, you have a PDF or a presentation and you want to make a quiz out of it, or you want to answer the quiz out of it. You don't want to put the whole information every time. So why not just put it as a static context so that the relevant information can be retrieved whenever is needed, right? Now with RAG, only the information that is most relevant. Okay, so the whole idea is to just extract the relevant information, not all of the information, right? And that relevant information is determined by something called as a retriever. The retriever will find only what is the question asking about, right? And they found that accessing the relevant information actually helped to mitigate hallucination. Okay, so Lewis actually found that this is a great approach because this approach of using RAG helped to mitigate hallucinations. Now, why is that? So this is, if you realize, the paper is published in 2020. Okay, this is back in the early days of the transformer model, right? And it is in the early days of large language models as a whole and everything, right? And this is actually, in the beginning, it was for NLP tasks. I think I've ruined it. Yeah, never mind. So in the beginning, it was for NLP tasks. So when I talk about NLP tasks, I think you understand what I mean. Basically, it is all the tasks are related to. Sorry, I just want. So now when I talk about an NLP task, I mean something that involves language processing, right? Anything that is related to language. Now, basically a chatbot. Roughly speaking, it's all about a chatbot at that point. This was back in 2020, right? Now, back in 2020, another very big problem that we still face is hallucination. So hallucination is a problem. It is has been a consistent issue with all of LLMs or transformer models, is that they tend to hallucinate. They tend to think up information. They tend to fake information which does not exist. So for example, if you ask, for example, today we are living in 2025 and the model for the chatbot you are using is has a, it's launched in 2025. It has a knowledge cutoff for 2025 only, and you ask it that who was the president of the USA in 2030. So now the model obviously does not know this. Nobody in the world knows this, right? Except maybe the CIA. But you asked it in past tense. So the model thinks that it has the wrong perception of time and it can fake any answer. It can say anything. It can even say Malala. Okay, it can say anything. So that's the whole point. It can say Narendra Modi if for, my Deshbhakt fans. I won't say fan. For my Deshbhakt. For any Deshbhakt watching this. And so it could be anything, okay? He could even say Obama. I hope it's Obama. So that is the problem with LLMs. Today, you would realize that most of the LLMs don't do that anymore because there are a lot of checks to ensure that hallucination is mitigated. However, if you use Gemini 2.5 or if you use Gemini 2 1.5 Pro, then you would have realized that Gemini had a very big tendency to hallucinate even in the past, like even in the recent years, when even though chat, like today also, you need good prompt injection attacks and you can get Claude or ChatGPT to hallucinate. It's not a big deal. So what he realized, what Lewis and his team realized, was that to mitigate this hallucination, if I just give this entire chatbot a document, that this is the information you have to refer to, by default you have to stick to this information, then the chatbot will actually hallucinate very less, since it will be busy finding the relevant information and getting it out. And if that information is not present here, I can just ask the chatbot to give that information that it's not in the document. It really helped, and this process is called grounding. So grounding is when we give the chatbot a ground to stand on, ki isse niche, you don't have to go below this, you just have to refer to this. You can refer to all your knowledge, you can refer to this. If you don't get any answer after that, fuck off. So then that's how at least it's hallucinating lesser. We still can't say that every LLM or any LLM is 100% hallucination free. We can never say that. All LLMs tend to hallucinate more or less, and I think that's what makes them so good at creative writing. I covered that in my previous lecture as well. When we talk about RAG, so in the early foundation days, RAG, in fact, I don't think that many of you would be in the research scene in 2020 or 2022 even, or 2024, even if you had started to catch up. RAG was a hot topic. I think till 2023, RAG was a very hot topic. Then agents became popular in 2023, I think. So whatever. So RAG evolution is one of the most common patterns, okay, in the early days of research, especially transformer or LLM, and it's the main purpose because RAG could help us get over the context limitations. So again, in the early days, if you had used ChatGPT in its first form in 2022, I think, then you would remember that ChatGPT had very small memory window. It had very small context window. It used to forget data context very fast. What is context window? Context window is that you have context window is basically the things that a chatbot can remember in one session. So imagine that you are using ChatGPT. Okay, this is your session window. Okay, now ChatGPT can only remember 1000 words. It's not like you, it doesn't have that good memory as you. We are trying to make it have a better memory, but in the early days, even today, it doesn't have that excellent form of memory. So it can only remember 1000 words, hard rule, right? So this is called as context window. That as soon as you're typing, you're talking to it, you're telling it, oh this, oh that, oh my this happened, oh my that happened, my friend did this, my friend did that, or whatever. And then after, as soon as 1000 words are hit, it will start forgetting stuff. Okay, even by the time you hit 800 words, it starts to forget minor details. But by the time you hit 1000 words, it has the ability, it can confidently say you've crossed the threshold, now I'll forget everything. Or you can, or simply with Claude, if you've used Claude just stops the window. That the context window is finished, just start a new chat. Because the model tends to forget. And then it is losing all the context, it loses all the information that you told it. And so you can't query back. Acha nahi, change this. Acha nahi, if you, for example, if you're asking it to code an app, right, and you ask it, oh no, change that. So the model doesn't remember what it made. It has no access to it, right? So that is a context window. And RAG actually really helped us to mitigate the problems with a context window. For example, like I mentioned that I am a teacher and I'm making quiz, right? And I have to make a quiz using the, the PDF of a book, and everything I taught during this is in the PDF, and I want to make a quiz out of it. So I have to paste this context or this PDF of text in the chat, so the window is gonna get lost in this. What I want instead, or let's take it from a student's perspective, that you have a quiz and it's from this book's PDF only. How can you make the LLM answer right? You will only give it the relevant. For example, if my question is on photosynthesis, why would I give the whole PDF about all of plant anatomy, right? It's not useful, right? So I will only give the section about photosynthesis. That's what RAG does. RAG is just going to this is your laptop. It's in a way attaching, okay, only this entire PDF, Now RAG is responsible to first retrieve relevant context, whatever is useful to us, and second, it will generate an answer of the quiz with regards to it. Okay. Now, what a lot of people think is that once we have sufficiently long context, we will not need a RAG anymore. I don't think it's true, because again, the whole problem is relevancy, right? If I have a very big context window, I would still my LLM would think that all of this is relevant, and it is very hard for the LLM to find relevance within a large context that is given to it. It is easier when it is in a PDF format. When see in the next slides, you will realize that we are talking about more techniques to make it more streamlined. So those techniques really help, and we have not done much engineering when it comes to context so far. Second is that the model cannot, let's say a model can process very long context, but that doesn't use the context as efficiently. Efficiency is a very big problem when you have a very large context. So the model is more likely to focus on a long issue. So for example, if I make you sit here and I speak for 5 hours, and and you are forced to listen to all of it, you would blank out in the middle, you would blank out in the beginning, you would forget only what is spoken in the end, and that what tends to happen to an LLM. I always compare an LLM to a child, and believe me, they have a lot of similarities. Okay. A fun fact is that Anthropic, which is the company that provides Claude, I really like their models because they are very good for coding. You should try it if you haven't. They suggested that for Claude models, if your knowledge base is smaller than 200,000 tokens, that means if your knowledge base is lesser than 500 pages, you should put it in context. It is okay if you put it in context, because then the model can retrieve it better instead of so if your PDF is less than 500 pages, you should paste it all of it in the context, because Anthropic as a model is better able to understand that. Okay. But if you have a very large PDF of 1000 pages or anything, then you should use RAG. So this is a very good technique, because this helps anyone who's using that model to know the limitations of the model, and the company is very open about it that you should do this, even though the company sometimes gives off fake data. I mean, it's inflated data. They just want to show that we have a 200,000 context window and you can check it. And it's true sometimes, but it's also a lie a lot of times. And when you check it, it fails. So take it with a, taste of salt, measure of salt. I don't know what's the saying, whatever is the phrase. So that's pretty much it. But still, it's very useful if companies give such good advice that you should try that, you should try this. Okay, then let's talk about the RAG architecture. So here is the RAG architecture. I'll just talk about it here only. So this is the RAG architecture that was introduced by Lewis and his team in their 2020 paper. As you can see, this is actually a very simplistic architecture. It has only two components, a retriever and a generative model, right? And a retriever is only going to get the relevant information. इसका काम ही यही है, to get the right information, and the generation model is going to use that information to generate the right answer for your question or whatever you are asking for. Okay, so but today we don't have this simple RAG architectures. Models have evolved. So again, this was in 2020. Today we are in 2025, and the speed with which this industry has skyrocketed when it comes to research is just mind-blowing. I'm also very young, but I don't think I have ever seen something similar. For example, I have seen the evolution of blockchain, and I don't think blockchain comes even close to the growth that AI industry has seen in the past 5 years. So that being said, the current RAG architectures are a little bit more complicated. Okay, the two components. Now earlier what happened is that they both were trained together. They are trained to build in a system to work together. Today we train the retriever alone, and a generator alone. So the generator is going to be trained only to generate based on the relevant information, and the retriever is trained to find the relevant information. Okay, we are focusing a lot on getting the right information extracted by the retriever or retrieved by the retriever. Okay, that's the whole thing. And many teams often, if you're building, for example, if you want to build a RAG system of your own, then it's better for you if you just get a pre-trained retriever and pre-trained generator and just put them together. If you fine-tune your entire RAG model yourself, however, obviously you will have much better results, because software rewards effort. Okay, you have to put a lot of effort in building that software, and then that software will just save hundreds of hours, but you have to invest a lot of hours in building that software also. So if you fine tune your own RAG system, then you will get the best responses 100%. But is it worth it to fine tune your own system? That's up to you to decide. Okay, now the success of a RAG system. How do you evaluate if my RAG system is good or not? If this retriever is good, or if that retriever is good, if this generator is good, or if that generator is good. Okay, that depends on, so the entirety, see the generator thing, no, it's not that big. It's just asking an LLM to get an output based on an input. It's just that. It's the basic question answering skill. Okay, this doesn't matter. When you are evaluating a RAG system, you are actually evaluating the retriever. कि इसने कितना relevant information retrieve किया, how much was it able to do. A retriever has two main functions. Okay, first is indexing. Indexing is processing the data. Okay, what happens is that you have, okay, now in your books, if you have ever read a book, you would know that there is an index. Okay, index is one number with this, and it's on page 23. Second thing is this, and it's on page 51. Third on this, and this on page 74, and something like this, right? And you would realize that this is very well indexed. If I want this context, then I can go to 23. If I want this, I can go on 51. So retriever has to index its content first. So for example, if my question was about photosynthesis, then it has to quickly see, okay, no, this is about photosynthesis. Okay, no, this is about plant reproduction. Okay, no, this is a plant excretion. Okay, yeah, I want this one. Right? Indexing is right. Second thing that a retriever has to do is query. Second thing that a retriever has to do is querying. Now, what is querying? Querying is basically the process of sending a query and getting relevant answer back. Okay, so if I am able to query right, for example, if my question was how does a plant does photosynthesis to survive, and it is able to query the right part of photosynthesis, indexed well to get the right answer about photosynthesis, that's good. But if I am asking about how does the plant excrete the wastes from photosynthesis, this query is actually supposed to go to this index. The indexing is done nicely, right? But what I wanted, but the query is not done nicely. I think I can explain it in a better way. So in my index, let's say I say photosynthesis is on page 21. I say plant reproduction is on page 30, and I say that plant excretion is on page 50. Okay, now my query is that how does a plant excrete the wastes from photosynthesis? That is a query that the retriever has to decide कि ये query would go to photosynthesis or would this query go to excretion. If I just ask what happens in photosynthesis and that query goes to photosynthesis and I get the right answer, then it's a good retriever. If I ask about this question, this is a complicated question, and that's where a RAG stands out. If it is querying right and getting the relevant information back, it is a very nice retriever. It is a very nice RAG system. That is it. Okay. Now, how does retrieval work? Okay, now let's talk let's talk about that. Okay, I'm starting this page. How does retrieval work? Now, how does a retriever function? How do we know that you should retrieve this part of the information, that I have this bigger document has all text? How does the model know okay, I just have to find this information, this is the only relevant information for me? Okay, the most straightforward way to find a relevant document is keywords. That's what you do. You just put Control F and you find whatever you want to find in a document, right? And this is called as lexical retrieval. When you are focused on the lexicography, okay? Now, if you want to query photosynthesis, I'll just Control F photosynthesis, and then I will, search for Control F excretion. That's way, right? The model will retrieve all the documents that have, or all the parts of the document that have information on photosynthesis. Now, the problem is that photosynthesis can be referenced many parts in the entire document. Photosynthesis is a very important thing for a plant. It is a part of its eating, it is a part of its sleeping, it's a part of its reproduction, it's actually part of its excretion also. It's a very big important thing. So, right? So, a right way, or the right way is to find which part of the document has photosynthesis the maximum number of times, right? Or let's say कि हमने अपने RAG system को we have given 5 books. We are not given 1 book, we have given 5 books. Yeah, 3 books, let's say 3 books. Okay, 1 book is entirely on photosynthesis, 1 book is on plant reproduction, and 1 book is on plant excretion. Okay, now and this is my entire knowledge base. That's a very big knowledge base, right? Now, when I do keyword searching, I am getting photosynthesis in all 3 of them. So, one way to find that which one is actually talking explicitly about photosynthesis is term frequency. Which document has the keyword maximum number of times? Maximum number of times, right? So term frequency matlab the term is occurring with maximum frequency in which document? That is called as this thing, term frequency. So it's a heuristic. It's actually a metric to measure the frequency of a term, and that is used in retrieval. Now, a prompt can be very long. Like I said, my original prompt was, how do we excrete the waste from photosynthesis? मेरी कान में थोड़ी चुल है and I want something very explicit. So a prompt can be very long and it can have a lot of terms. When I say that, how does a plant excrete the waste after photosynthesis? So these are the 3 main keywords, right? Now इसमें से you have to find which keyword is the main keyword. Excrete या photosynthesis, waste disposal की बात हो रही है, तो now these are a lot of words and you need to find a way to identify, to rank them. So what is the intuition? So how would you do it? How would you do it if you were to do it? Is that more a document contains a term, yeah, so how do you do it? So you will just say कि अच्छा, अगर तीनों डॉक्यूमेंट्स में फोटोसिंथेसिस की बात हो रही है, ठीक है, ये मेरे 3 कीवर्ड्स हैं, एक्सक्रीट, वेस्ट, फोटोसिंथेसिस, है ना? अब इनके बाद मेरा क्वेश्चन तो लेकिन बहुत बड़ा था ना, तो मेरा ये मुझे पता है एज अ पर्सन कि ये मेरे 3 कीवर्ड्स हैं, पर मेरा एक क्वेश्चन था, हाउ विल यू एक्सक्रीट द वेस्ट फ्रॉम फोटोसिंथेसिस. अब हम ये देखेंगे कि जब मैं फ्रॉम सर्च कर रही हूँ तो फ्रॉम तीनों में बहुत बार आ रहा है. जब मैं विल सर्च कर रही हूँ वो तीनों में बहुत बार आ रहा है. जब मैं हाउ सर्च कर रही हूँ वो तीनों में बहुत बार आ रहा है. जब मैं यू सर्च कर रही हूँ, द सर्च कर रही हूँ, ये तीनों में बहुत बार आ रहा है. और तीनों में ही सिमिलर फ्रिक्वेंसी में या तीनों में ही बहुत ज़्यादा फ्रिक्वेंसी में आ रहा है. दैट मीन्स कि इट्स नॉट अ रेलिवेंट कीवर्ड. इट इज़ नॉट एन इन्फॉर्मेटिव वर्ड. ये इन्फॉर्मेटिव है ही नहीं. तो हमने ये रियलाइज़ करा है कि टर्म फ्रीक्वेंसी इज़ इन्वर्सली प्रोपोर्शनल टू द नंबर ऑफ डॉक्यूमेंट्स. मतलब टर्म फ्रीक्वेंसी इज इन्वर्सली प्रोपोर्शनल टू द टर्म्स इम्पोर्टेंस. ठीक है. सो दिस मेट्रिक इज कॉल्ड एज इन्वर्स डॉक्यूमेंट फ्रीक्वेंसी. ठीक है. इन्वर्स डॉक्यूमेंट फ्रीक्वेंसी इज़ IDF. और ये बहुत इंपॉर्टेंट है क्योंकि ये हमें बताता है कि इन्वर्स डॉक्यूमेंट फ्रीक्वेंसी जितनी ज़्यादा होगी उतना इम्पॉर्टेंट वो टर्म है. ठीक है. मान लो तुम्हारे 3 डॉक्यूमेंट हैं और इन तीनों डॉक्यूमेंट में मेरा मान लो वर्ड था यू आ रहा है 9000 बार 3 डॉक्यूमेंट्स में, यानी इसका IDF है 3000. ठीक है. सो और अगर मैं कहूँ फोटोसिंथेसिस है, फोटोसिंथेसिस इन तीनों डॉक्यूमेंट्स में मिला के आ रहा है 300 बार, तो उसका IDF है 3. तो ऑब्वियस सी बात है ना, फोटोसिंथेसिस इज़ अ मोर इम्पॉर्टेंट वर्ड. वो कम बार रेफ़र हो रहा है. ऐसा भी हो सकता है कि अब जैसे मान लो ह्यूमन हमारी पूरी उसमें आ रहा है 60 टाइम्स. तो ह्यूमन का तो IDF और कम है. ह्यूमन तो और इम्पॉर्टेंट होगा फूड प्लांट के लिए, पर ऐसा नहीं है ना. प्लांट की लाइफ में ह्यूमंस की ज़्यादा वैल्यू नहीं है. तो दिस इज़ नॉट, अगेन दिस इज़ ऑल्सो नॉट 100% रिलायबल, बट दिस इज़ अ वेरी गुड मेट्रिक टू एटलीस्ट रिमूव द एडवर्ब्स, द एडजेक्टिव्स, द नॉट इम्पॉर्टेंट वर्ड्स. ठीक है. ये था. इस पूरे प्रोसेस को हम कहते हैं, मतलब प्रोसेस तो नहीं कहूँगी मैं, इसको हम कहते हैं tf-idf एल्गोरिदम. ये एक स्पेशल एल्गोरिदम होता है जस्ट फॉर दिस पर्पस, रिट्रीवल पर्पस के लिए. ऐसे ही हमारे पास एक और एल्गोरिदम होता है, मुझे अभी चाहिए नहीं. ओके, इरेज कर देते हैं. ऐसे ही एक और एल्गोरिदम होता है BM25. BM25 is a very popular algorithm and it focuses on something called as matching. In fact, BM का मतलब वो नहीं है जो आप चाहते हो. BM का मतलब है बेस्ट मैचिंग. BM25 मतलब बेस्ट मैचिंग का 25th एल्गोरिदम. कितनी बढ़िया चीज़ है ये. एंड BM25 1980s में इनफैक्ट आया था. ठीक है. और इट नॉर्मलाइजेस टर्म फ्रीक्वेंसी. ओके. एंड इट स्कोर्स बाय डॉक्यूमेंट लेंथ. इसमें एक नॉर्मलाइजेशन फंक्शन इन्वॉल्व होता है जो कि थोड़ा मैथमेटिकल है, बट वी आर नॉट गोइंग टू कवर दैट इन डिटेल. Basically, longer documents are more likely to contain a given term and they will obviously have higher term frequency. जो IDF में जैसे हमने देखा था कि अब अगर मान लो ये 300 पेज का है, ये 100 पेज का है, तो ऑब्वियस सी बात है ना, इसमें कोई चीज़ कम ही होगी क्योंकि सिर्फ 100 पेज का ही है. तो सिर्फ TF-IDF लगाना इज़ अ बैड आइडिया. हमें डॉक्यूमेंट लेंथ भी ध्यान रखनी पड़ेगी. ठीक है. इसके बहुत वेरिएंट्स हैं एंड दे आर स्टिल वेरी कॉमनली यूज्ड to compare against retrieval algorithms. अब आगे चलने से पहले there's something that we have to discuss that we haven't yet. is called tokenization. वैसे तो मैंने अपने फर्स्ट लेक्चर में टोकनाइजेशन आई थिंक काफ़ी डेप्थ में कवर किया था, बट अगेन इफ़ you have not watched it, the link is in description and you can see it a brief overview also here. So tokenization is the process of breaking a query into individual terms. Okay. So if you have any query, for example, what is a plant? Okay. So what is a plant? This is broken down into different parts. So again, tokenization is the process of breaking a query into individual terms. ठीक है. सिंपलेस्ट मेथड जो अभी हमने करा है वो यही है कि हमने वर्ड्स को ही तोड़ दिया, मतलब स्पेस सेपरेशन. बट ये क्या होता है, दिस इज़ नॉट अ वेरी गुड आइडिया बिकॉज समटाइम्स वर्ड्स लूज देयर मीनिंग. फॉर एग्जाम्पल मैं कहूँ वॉट इज़ अ हॉट डॉग. अब मैं इसको भी तोड़ दूंगी हॉट में और डॉग में. अब गरम कुत्ता इज़ नॉट वॉट वी वॉन्ट. हॉट डॉग इज़ अ डिफरेंट टर्म इंटायरली, right? So there are a lot of ways for tokenization. Sometimes we also remove words ending with ing, or we treat the, is, and separately, right? So there are a lot of libraries that we use for it, like NLTK, or these are basically NLP packages, and Spacey, right? And there are a lot of tokenization. Basically there are a lot of packages or libraries in Python that helps us with tokenization, and the main process of tokenization is very important to make sure that our query is being properly conveyed to more language model. What is embedding based retrieval? First, let's understand what is embedding. Again, embedding also I think I covered in my first lecture, and before talking about embedding based retrieval, I want to make sure that you understand what is an embedding. So for an embedding, you should know what is a vector. Okay, so what is a word vector? Word vector is, for example, I say a word king, okay, and I want to convert it into a vector. Let's say I wanted to convert it into a 3-dimensional vector. So then king would transform into some word coordinates, let's say 3, 1, minus 6. Okay, and let's say king and queen are related words. So queen would become 3, 1 plus 6. Let's just assume. So this is the location of king and this is the location of queen. They're directly opposite, but they're connected by a line, right? That's how you know that they are related somehow. Okay, so that's the concept of having vectors. Okay, now embedding is typically a vector which is made to preserve the important properties of the original data. What happens is that if I have a word running, I'll convert running into run plus ing. Okay, I'll tokenize it into 2 words and then I'll convert it into vector. So this vector is basically preserving, it's a vector that is made. Now when I make a running, cut. So for example, I have a word, I am using the word king only and I convert it into a vector. Now in vector embedding, I'll call it as a vector embedding because vector embedding is basically used to preserve the important properties. Ki this king, what the original word was king. So it's like, when I have to go it back. So a vector embedding or an embedding based retriever, when we talk about, it doesn't work if the embedding created is bad. So there is an algorithm that converts any word into an embedding vector. Okay, and if this embedding algorithm is bad, then obviously you cannot have a very good embedding based retrieval method. Okay, now let's talk about why do we have vector embeddings, vector based retrieval. Why did this go? Okay, so the thing is that text doesn't necessarily capture meaning. Okay, just text. Now there is a way to understand the meaning behind the text. Sometimes the person can be asking something rhetoric. Sometimes the person can be asking something, but they actually mean something else. They can be giving a description of, there's an animal which is orange in color and it looks like a cat and it has black stripes on it. It looks very fierce, which is that animal. Now, this is a very difficult thing for a large language model or for a child to comprehend, right? So what will happen, we can actually in the RAG system, we can actually go through different kinds of animals. We can actually go through different documents and get out, and the retrieval could give us irrelevant things, right? For example, if you query transformer architecture, okay, it can query out something about the movie Transformers, right? It could be anything. You ask about you could ask about orange and it will give, you are asking about the fruit orange, it will give you the color orange. It's just very normal, for stuff like this to happen, and it used to happen. So embedding based retrieval actually is very useful when for things like this. Now, why is that? That's because embedding based retrievers rank the document based on how closely they align with the query, right? Now, basically, this is basically about ranking relevance. Okay, this is called as semantic retrieval, first of all. Instead of, if you remember, originally we were discussing tf-idf and BM25, and we talked that it's called lexical retrieval, where we focus on the keywords, right? Now, here what is happening is, when the embedding based retrieval is going on, indexing is done, to convert the original data chunks into embeddings. So, जो हमारा data था, that is converted into embeddings, right? So that is converted into the vector here, and now our query is also converted into a vector. And so we find ki, okay, let's assume this is a query, this is our query, and query is in red, okay, and the data is in yellow. So one thing about data talks about here, here, here. These are the key points that the data talks about somewhere, okay. These are located in the vector data space. Now, if my query has any word which is located here, okay, what can I understand from this? I can understand from this that this is a very close word to my query. This is a very close word to my query. This is a little far, this is a little far, this is very far, this is very far, so this is not relevant. I don't care about this. I may care about this, but I definitely care about this. Why? Because this is very close. If I had king, this maybe had queen, or this may have prince, or this may have kingdom, or this may have money, or this may have rich, or something that is relevant to my query, right? So that is the whole point of embedding vectors, that we are preserving the essence of the word in relation to other words of the English language. I think this is a very important concept to understand, to grasp. And if you didn't understand it, then please feel free to leave a comment and maybe help me out with some feedback, because right now I don't have any. I would love some feedback on this. Okay. Now, based on this query, okay, we are going to do two steps. First is embedding model. So the embedding model, we will use the embedding model. The same embedding model that converted our data into embedding will convert the query into embedding. That's the first thing that we do. Second is the retriever. We'll put this query here. Okay. Now the retriever is going to fetch the top k similar things. So this is the first similar thing. This is the first similar thing. This is the second similar thing. This is the fourth. This is the fifth. This is the sixth. Okay, ऐसे आ रहा है. So अब now we are going to rank them. कि first similar word embedding ये है, second similar word embedding ये है, third similar word embedding is this, and then we are again going to use the embedding model to convert them into the words that they actually were. Okay. And that is how a vector-based embedding works. And what happens is that usually, since these contains the actual meaning of the words, we can find them more closely, because this is semantic. This is in relevance. So see, your query vector is not just one word. Your query, oh fuck. Yeah, your query vector is not just one word. Your query vectors is a mixture of words. So let's say one word is here, one word is here, one word is here, one word is here. That means this is the best word, na? All the words are closer to this one. Okay. And then similarly, this could be second number, this could be second number. Okay. Now, another thing that came out of vector embeddings and using them for retrieval is vector databases. You see, vector databases are actually a product of embedding-based retrieval, because this method is so efficient in capturing the meaning of words, of different words. It can tell you the relationship between different words. Now, this way you're not only seeing from the perspective of the word king, you are seeing from the perspective of the word prince, you are seeing from the perspective of the word kingdom or palace, or you can see everything that is surrounding it. So it's a very, very efficient method, and this gave birth to vector databases. Okay. And a vector database is basically a database that stores vectors. Okay. Storing is actually the easiest part about a vector database. The hard part about a vector database is vector search. If you have some experience in building any kind of systems or with software design, you would have learned about database. Okay. If you have, then you might have heard about database management systems. You might have heard about SQL or NoSQL or Postgres or PostgreSQL, right? And other. So basically, what are these? SQL stands for structured query language. It is a language that is used to query a database, right? A relational database. So similarly, I won't say similarly. So SQL is used to query through a relational database. Now what happens is that it's a language. Okay. But what is that language doing? That language is in essence searching through stuff of the database. This is your database. It's a table. And when you write a SQL query, select star from this, then you are going to get the information from this. So the whole thing it's doing is it's doing search. Okay, it's redefined, but it's search in the form of prompts. Yeah, can you find the relation? It's kind of like you're prompting for a search. That is not there yet for vector search. We currently only have vector search, and this is a vector database, and it has large vectors stored. Now vector search is very hard currently. Okay, we have to find the vectors that are similar to the vectors in the database, right? Which are, we have query vectors, and we have to find database vectors that are similar to them, right? Now there are many mechanisms in generative AI applications for vector search, but we still don't have accomplished this with efficiency. Okay, and but vector search is very important, and it is actually a backbone of any vector database today. Okay, you have search systems, you have recommendation systems. We have built very good, very efficient vector search mechanisms, but I think we still have a long way to go. Now today, the most in the beginning, the easier one was KNN, K nearest neighbors, the whole thing. So this is what I was telling you here. This is called KNN. If I say I want the top 5 nearest neighbors, then by this logic, we are going to get the top 5 nearest neighbors. Okay, and we are going to rank them. Now, how does it work? It computes the similarity scores between So how does CNN work? This is my three-dimensional vector space. These are my words in my database, and this is my query vector. Okay, so what I'll do is I'll find the similarity score between these, right? Like this, I will find the similarity scores between my query. This is my query embedding, the yellow one, right? And the red ones, this is my query embedding, right? And the red ones are my data embeddings. I'll find a similarity score between them. Which one is matching? I think this one is matching well, this one is matching well for both the query parameters, right? And and there are metrics called cosine similarity. It's a score. It gives cosine similarity, gives me a score which word is nearest using maths. Okay, we use trigonometry to find the cosine similarity, and then based on this we rank all of these database vectors. Okay, and I think the ranking would go something like this would be 1, this would be 2, then I'm very confused. This could be 3, let's say this could be 4, this could be 5, and stuff like this. So I have to give the top 5, I'll return these top 5 words. I'll convert them back into words and I'll return them. Okay. But this is not very efficient when it comes to a large data set, because you see in a large data set there will be 100,000 data points. Like all of the green dots are also words, and they are like so dense. How can you find it? You need something like ANN. ANN means approximate nearest neighbor. It could be that it's a large data set. Another problem with a large data set could be that everything is just too far apart. And now my query vector is here. Both of the things can happen. It depends on how you're building the data set. Okay, but we are not. So if you have heard about FACE is Facebook AI similarity search. So it's a similarity search. It's a search, vector search. It's a vector search algorithm that they built for their own vector database. And it's very useful. It was open source and it was very, 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 very useful in the early years. This was built in 2017. And this was very useful. I can't even emphasize that for the first few years, this was actually a backbone of the vector database search algorithms. But since, as AI, if you're building AI engineer, if you're doing AI engineering in production environment, you don't have to concern yourself much with it. I'm just going to mention some of the vector search algorithms that you can read about if you want to. First is LSH, locality sensitive hashing. Second is HNSW, which is hierarchical negative small world. Third, yeah, it has weird names. I think my favorite one is the Spotify's what's it called, Annoy. Spotify's Annoy is a nice one, and the name of the paper is actually approximate nearest neighbor. Oh yeah. And then you have inverted file index. It's IVF, but again not the kind you want. And these are some of the ones that are good enough. Now, if you remember, I mentioned that if you want to evaluate a RAG model, which is the final step you have to do, you will have to evaluate the retriever. How is it getting relevant information, right? Two metrics are used here: context precision. Context precision means that out of all documents retrieved, out of all documents retrieved, what percentage is relevant to our query? That's context precision. Second that we have is context recall. I think if you have some knowledge about ML basics, you would know about precision and you would know about recall, and that would really help you. Okay. Again, out of all the documents received, what percentage is retrieved? Okay. of all the documents relevant to the query. So मान लो you had 10 documents, out of which one document is actually relevant to the query. Okay, so this is a fact that you know. So precision now, and if we fetched 3 documents, okay, so then precision would be that out of all the documents, what percentage is relevant to the query. So that would be 1 out of 10. That is precision. And recall is when out of all the documents relevant to the query, it was only 1. 3 were fetched. So it could be high, it could be low, it shouldn't be high, it shouldn't be low. It's just, this is how you can evaluate. Then there are benchmarking techniques also, like with query per second or build time or indexing size or indexing time. There are things like that. Now there are some things that I would like to mention is optimization techniques. You might have heard of them. First of them is chunking. Chunking is when you have a very big document, and you chunk it into smaller sizes. But you should remember that the chunk size should not exceed the context length of our model. Okay. Now, depending on the tasks, some tactics, can be used. So chunking is one of them, so that we can get relevant information. Okay, now अब chunking के अंदर what we do is we have a very large document, we divide it into parts, okay, and then we chunk it basically, and then we pass it on to the language model. And you can split the document, and it is always recommended to do some sort of overlap. So for example, you're cutting from line number 10. So to ensure that line number 11 ऐसा हो सकता है ना कि it's a mid sentence, right? So so you should chunk again from line number 9. Okay, so आपने यहाँ से काटा. Okay, let's focus here. This is how you're chunking. Okay, so you should have some overlap. The first document is from here. The second document, why is it? Oh, this is black. The second document should be from here. And it's from here. ऐसे इतना बड़ा है second document, इतना बड़ा है first document. तो ये क्या है? ये थोड़ा overlapping हो रहा है, and this overlapping is very good to ensure that all of the context is captured. There is no empty sentences. The second technique that you can do is re-ranking. What is re-ranking? So what happens is the initial document ranking जो होती है, that is generated by the retriever, it can be re-ranked to be more accurate. Okay, if you want to reduce the number of retrieved documents. So for example, your retriever first gives you 10 documents that are relevant. Okay, what you will do, you will ask it to re-rank based on these 10 documents. So then you will get to only give you 3 documents. That gives you a better idea, and this is very useful when you have a time sensitive method, for example web search, real-time web search, or news applications, or stock market analysis, because context re-ranking is very important to rank, because it can get you 10 things that are relevant, but in the first iteration it might seem that the first thing is more relevant when actually it might not. So the order of documents is very important when you are ranking or when you're evaluating a retriever. And so if you do re-ranking, it's like double checking to ensure that you're only getting the most relevant information. I think that's mostly all the theory that is involved in building a RAG system. I would try to help you explain the agentic systems also next, but till then, like, share, subscribe.